How's it going, Accelerated Chemistry? This is Mr. Spurk, and this is your Chapter 18, Section 5 notes on free energy and entropy. Some of the energy released in a chemical reaction can be harnessed to do work, such as pushing the pistons in an internal combustion engine. And an internal combustion engine is a simple engine, such as the engine in your vehicle. The energy that is available to do work is called free energy. You can write a balanced equation for a chemical reaction, but the reaction may not actually take place. So we have carbon dioxide gas yielding carbon solid plus O2 gas. Carbon and oxygen react to form carbon dioxide, but not in the reverse manner that this is written above. Some balanced equations occur, the others represent reactions that do not tend to occur, or at least they don't occur efficiently. A spontaneous reaction occurs naturally and favors the formation of products at the stated conditions. Spontaneous reactions produce large amounts of products and release free energy. A chemical reaction that does not favor the formation of products at the stated conditions is called a non-spontaneous reaction. They produce little, if any, product. In nearly all reversible reactions, one reaction is favored over the other. Consider the decomposition of carbonic acid in water. The forward reaction is spontaneous and releases free energy. However, the reverse is non-spontaneous, so carbonic acid decomposes to CO2 and H2O spontaneously. That occurs, but we cannot combine CO2 and H2O and just assume that or think that we will get carbonic acid. The terms spontaneous and non-spontaneous do not refer to the rate of the reaction. Some spontaneous reactions are so slow that they appear to be non-spontaneous. Changing the conditions of a chemical reaction can affect whether a reaction will occur. So now we're going to talk about coupled reactions. Sometimes a non-spontaneous reaction can be made to occur if it is coupled to a spontaneous reaction. One reaction releases energy that is used by the other reaction. Coupled reactions are common in the complex biological processes that take place in living organisms. You might expect that only exothermic reactions are spontaneous. Some processes, however, are spontaneous even though they absorb heat. Some factor other than the enthalpy change, which is heat, must help determine whether a physical or chemical process is spontaneous. The other factor is related to order. Entropy is a measure of the disorder of a system. The law of disorder states that the natural tendency is for systems to move in the direction of increasing disorder or randomness. So the more random or the more disorder there is, the higher the entropy. Entropy can affect the direction of a reaction. Reactions in which entropy increases as reactants form products tend to be favored. For a given substance, the entropy of the gas is greater than the entropy of the liquid or the solid. Thus, the entropy increases in reactions in which solid reactants form liquid and gaseous products. Entropy increases when a substance is divided into parts. Entropy tends to increase in chemical reactions in which the total number of product molecules is greater than the total number of reactant molecules. Entropy tends to increase when the temperature increases. As the temperature rises, the molecules move faster and faster, which increases the disorder. The size and direction of enthalpy changes and entropy changes together determine whether a reaction is spontaneous. Consider an exothermic reaction in which entropy increases. The reaction will be spontaneous because both factors are favorable. A reaction can be spontaneous if a decrease in entropy is offset by a large release of heat. So if delta H is very large and delta S is very small, the reaction will be spontaneous. And an increase in enthalpy is offset by an increase in entropy. So this is a really nice table. You're going to want to copy this down, and you can make it a little more brief than what it is here, but you're going to want to be able to look at systems and apply them to the chemical or apply them to the mathematical equation that we're about to look at. So would the following exothermic reaction be spontaneous? Explain why or why not. So we have KClO3 decomposing to KCl plus O2. So when we look at this, we see that there are 2 molecules of solid transformed into 2 molecules of solid and 3 molecules of gas. So the entropy increased because we went from a total of 2 molecules on the left to a total of 5 molecules on the right. That's an increase in disorder, or an increase in entropy. A reaction that is exothermic with an increase in entropy will be spontaneous. So that exothermic means that we had an increase in delta H, and now we have an increase in delta S. So we're going to have we have a spontaneous reaction. So now we're going to look at the free energy change. Free energy is often expressed as Gibbs free energy. Free energy, G, can either be released or absorbed during a physical or chemical process. The equation below is used to calculate the change in Gibbs free energy. So delta S is our change in entropy, delta H is the change in enthalpy, and T is the temperature in Kelvin. When the value of delta G is negative, the process is spontaneous. When the value is positive, the process is non-spontaneous. The entropy change for the following reaction at 298 K is 3.0 joules per mole K, and the enthalpy change is negative 394 kilojoules per mole. So what we need to do is look at the chemical equation. So we have carbon plus O2 yields CO2, and we want to calculate the Gibbs free energy change and determine whether the reaction will occur spontaneously. So, before we get there, we're going to calculate this very briefly. So we're going to use that chemical equation, delta G equals delta H minus T delta S. So delta G equals negative 394 kilojoules per mole minus the temperature in Kelvin, 298 K, times delta S. But if you notice, this is in joules per mole Kelvin. So we need to convert that to kilojoules so we can have some proper subtraction. So 0.003 kilojoules per mole Kelvin. And when we multiply these two together and then subtract it from the enthalpy, delta G equals negative 395 kilojoules per mole. So this delta G is negative, which means this is a spontaneous reaction. Alright, so in review, spontaneous reactions produce large amounts of products and release free energy. Reactions in which entropy increases as reactants form products tend to be favored. The size and direction of enthalpy changes and entropy changes together determine whether a reaction is spontaneous. When the value of delta G is negative, a process is spontaneous, and when the value is positive, a process is non-spontaneous. As always, all the information on these slides has been acquired and adapted from Pearson Chemistry, 2012 edition of the textbook, the resources CD, and pearsonchemistry.com. Have a great rest of your day.